A test is happening right now. This is not a theoretical exercise, nor an academic discussion at a conference. It's a direct observational experiment, an event that will answer a question no one dares to speak aloud. The object known as 3I Atlas has exhibited a non-gravitational acceleration during its passage through perihelion, and this is documented, recorded, and confirmed by multiple instruments, including NASA itself. Physics is unforgiving. It allows no loopholes. If that acceleration was caused by natural outgassing, as happens with comets when part of their ice sublimates under the sun's heat, then the law of conservation of momentum demands that Atlas must have lost at least 1/6 of its total mass. We're talking about roughly 5 billion tons of gas released into space. 5 billion tons. Such a colossal volume of material should form a brilliant, enormous cloud, impossible to miss, a spectacular cometary tail, visible even through amateur telescopes, a glowing trail cutting across the sky. But now comes the crucial moment. When 3I Atlas emerges from behind the sun in just a few days, we'll either see that cloud or we won't see anything at all. And if nothing appears, we'll have to face a possibility many scientists desperately avoid considering. On November 2, 2025, the Lowell Observatory in Arizona captured a new image of 3I Atlas. Astronomer Kang Zhang used a 152mm reflector telescope and managed to record the object clearly. Its structure is visible, defined, but something is missing: the tail. Or rather, the colossal tail that, according to all known physics, should be there. Before assuming this is simply due to observation conditions or brightness, it's crucial to understand what the data actually show. This isn't just a single photograph. It's multiple lines of evidence converging toward a disturbing conclusion. The brightness curve of 3I Atlas, built from months of observations with different instruments, shows a consistent light profile. The model lines, one representing the gas coma and the other the dust component, align perfectly with the observed data. The brightness increased as the object approached the sun, peaked at perihelion, and is now gradually fading. All normal, all in line with expected cometary behavior. But this apparent normality might conceal the most unsettling anomaly of all. The ALMA radio telescope array, located in Chile's Atacama Desert, detected 3I Atlas during its solar approach, and noticed something that cannot be ignored: a 4 arcsecond deviation in right ascension from the predicted trajectory. 4 arcseconds may sound small, but in orbital terms, it's a massive discrepancy, one that demands an explanation: a force acting beyond gravity. Harvard physicist Avi Loeb analyzed the data using conservation of momentum. If the acceleration came from outgassing, then material ejected in one direction must push the object in the opposite direction. It's an unavoidable consequence of physics. When applying the calculations, Loeb found that the level of acceleration reported by NASA's Jet Propulsion Laboratory implied the loss of roughly 1/6 of the object's total mass, a colossal amount. This wouldn't be a mere surface evaporation, but a catastrophic sublimation, an event capable of destroying a substantial fraction of the entire structure. If that really occurred, there should be a gigantic cloud surrounding Atlas, containing billions of tons of gas, dust, and particles, a plume so vast and bright it would be impossible to miss. Therefore, when Atlas re-emerges from behind the sun, something expected within a week or two, it should appear surrounded by a dazzling cloud, visible even to the naked eye. And if none of that appears, only one question remains: what then is propelling this object? There's no way around it. If 3I Atlas lost 20% or more of its mass due to solar evaporation, that would be unmistakable. It would change its density, alter its structure, and leave an undeniable observational signature. But what if none of that is there? The most troubling reminder comes from the case of Oumuamua, the first confirmed interstellar visitor. It too showed non-gravitational acceleration, with no sign of outgassing, no coma, no tail, nothing to explain the thrust. Yet it accelerated. Lowell proposed that perhaps it was being pushed by solar radiation pressure reflected off its surface. And a few years later, the case of Object 2020 reinforced that idea. That object, discovered by the same Hawaiian telescope, turned out to be a rocket booster from 1966. Its spectrum showed stainless steel, and it behaved exactly like a hollow, lightweight object being pushed by sunlight. Based on that, Loeb suggested perhaps Oumuamua was also artificial. In the case of 3I Atlas, we know there's gas around it, detected since its discovery when it was still far from the sun. The question is, now, after closest approach, is there more gas? Does the increase in brightness match the expected mass loss? If the massive cloud isn't there, we must consider that something else is driving it. A spacecraft, for instance, could use controlled propulsion without ejecting huge amounts of gas. Or, as Loeb himself pointed out, maybe the object is made of reflective material, like polished steel or nickel, reacting to sunlight in a specific way. It sounds unlikely, but it's possible. And the most frustrating part of this entire story is that there are high-resolution images captured by the HiRISE camera aboard NASA's Mars Reconnaissance Orbiter when 3I Atlas passed near Mars in October. HiRISE is the most powerful imaging instrument in Martian orbit, capable of resolving details as small as 30 centimeters. The Atlas photos, if released, would have 3 times the resolution of the Hubble Space Telescope. They exist. They've been captured, processed, and archived, but so far, they have not been made public. Loeb attempted to contact the camera's principal investigator. No response. Congresswoman Anna Paulina Luna even sent a formal letter to acting NASA Administrator Shaw Duffy on October 31, requesting the release of the images. No reply. Curiously, the same administrator quickly responded to a social media celebrity, Kim Kardashian, when she asked about Atlas. Loeb saw this as a troubling reflection of priorities. The public gets fast answers, while scientists and lawmakers are ignored. The official justification is the partial government shutdown. But for Loeb, withholding globally significant scientific data is unjustifiable. After all, astronomers worldwide are planning new observations based on incomplete information. And ironically, while bureaucracy stalls the debate, the universe itself is already delivering the answer. The JUICE spacecraft, the Jupiter Icy Moons Explorer from the European Space Agency, began observing 3I Atlas on November 2, 2025. Though its main mission is to study Jupiter's icy moons, it now has a unique opportunity to observe an interstellar object just 60 million kilometers away. Unlike Earth-based telescopes, still struggling against the sun's glare, JUICE has a clear view, free of atmospheric interference. It's equipped with powerful instruments, sub-millimeter wave detectors for water molecules, energetic particle sensors, infrared and ultraviolet cameras. In the coming days and weeks, it will reveal whether or not there truly is a cloud of billions of tons of gas surrounding Atlas. And it's simple. If that cloud exists, it will be unmistakable. No instrument could fail to detect something so massive. There are only 3 possible outcomes. The cloud is there. This would confirm that 3I Atlas is a natural comet, whose acceleration was caused by extreme but physically understandable outgassing. Mystery solved. A small cloud exists, but far too little to account for the measured acceleration. That would pose a serious problem, since momentum conservation isn't optional. If the acceleration is real, but the gas isn't there, another force is at work. No detectable cloud. In that case, no natural explanation remains. We'd have to admit that Atlas isn't a typical comet, but perhaps something different, something moving under control. When the new Lowell Observatory images were released, astronomers' reactions were almost defensive. Obviously, it's not a spacecraft, they said, it's just a comet. But the absence of a tail is glaring, and repeating that it's obviously natural doesn't substitute for a physical explanation. Meanwhile, headlines in the United States read, "Alien spacecraft accelerates mysteriously. Scientists respond." Authorities urge caution, saying it's too soon to draw conclusions. But physics doesn't wait for our prudence. Either there are 5 billion tons of gas, or there aren't. Either momentum is conserved, or it isn't. In the coming days, the data from JUICE and from ground-based observations will tell the whole story. There will be no room left for interpretation. If the cloud is there, the case will close as a natural phenomenon. If it's not, we'll have to admit we don't understand what we're observing, and that perhaps Atlas is the second interstellar visitor to completely defy our categories. Maybe Oumuamua wasn't an isolated anomaly. Maybe 3I Atlas is the second confirmation of a pattern. Maybe artificial interstellar objects cross our solar system more often than we imagine. The truth won't come from official statements or academic debates. It will come from observations, from cold, undeniable data. The 5 billion ton cloud is either there, bright and obvious, or it isn't. And whatever the outcome, we'll have to accept what the universe shows us. It doesn't care about our expectations or what we're ready to admit. The cosmos simply is. And very soon, we'll know what 3I Atlas truly is: a natural fragment from a distant world, or something that carries the signature of an intelligence traveling among the stars.